Quiz Corner. Welcome to First Step. Like, share and subscribe. Question 1. A cylindrical conductor of length L, and inner radius R1 and outer radius R2 has specific resistance ρ. A cell of EMF E is connected across the two lateral faces of the conductor. Find the current drawn from the cell. Choice A, 2 pi L E divided by ρ into ln R2 by R1. Choice B, 2 pi L E divided by ρ R2 square minus R1 square. Choice C, 2 L E divided by ρ into pi into R2 square minus R1 square. Choice D, none of these. Correct answer. 2 pi L E divided by ρ into ln R2 by R1. Question 2. Two wires A and B having resistivity ρ A equals 3 into 10 power minus 5 ohm meter, and ρ B equals 6 into 10 power minus 5 ohm meter of same cross-section area, are connected end to end to form a single wire. If the resistance of the joined wire does not change with temperature, then find the ratio of their lengths given that temperature coefficient of resistivity of wires A and B are alpha A equals 4 into 10 power minus 5 a degree C and alpha B equals minus 6 into 10 power minus 6 a degree C. Assume that mechanical dimensions do not change with temperature. Choice A, 3 by 7. Choice B, 10 by 3. Choice C, 3 by 10. Choice D, 1 by 2. Correct answer. 3 by 10. Question 3. A positively charged rod is brought near to a non-conducting object. The rod is attracted to the object. From this observation, we can't predict whether the object is charged or uncharged. Some additional experiments have been performed to identify whether the object is charged or uncharged. These experiments with their observations and conclusions drawn are given. Select the option in which conclusion drawn is correct. Choice A, a negatively charged rod is brought near to object and the two attract. This shows that the object is neutral. Choice B, a negatively charged rod is brought near to object and the two attract. This shows that the object is negatively charged. Choice C, a negatively charged rod is brought near to object and the two repel. This shows that the object is negatively charged. Choice D, all the above. Correct answer. All the above. Question 4. 5 balls numbered 1, 2, 3, 4, and 5 are suspended using separated threads. The balls 1, 2, 2, 4, and 4, 1 show electrostatic attraction while balls 2, 3, and 4, 5 show repulsion. Therefore, ball 1 must be Choice A, negatively charged. Choice B, positively charged. Choice C, neutral. Choice D, made of metal. Correct answer. Neutral. Question 5. A point charge plus Q is placed at a distance d from an isolated conducting plane. The field at a point P on the other side of the plane is Choice A, directed radially away from the point charge. Choice B, directed radially towards the point charge. Choice C, directed perpendicular to the plane and away from the plane. Choice D, directed perpendicular to the plane, but towards the plane. Correct answer. Directed perpendicular to the plane and away from the plane. Question 6. The electron in an hydrogen atom moves in a circular orbit of radius 5 × 10⁻⁻11 meter, with a speed of 0.6 pi × 10⁻6 meter per sec. Then, 1. The frequency of the electron is 3 × 10⁻15 revolutions. 2. The electron carries 3.2 × 10⁻⁻19 coulomb charge around the loop. 3. The current in the orbit is 0.96 milliamps. 4. The current flows in the same direction in which the motion of electrons. Choice A, a positive. Choice B, a negative. Choice C, no net charge. Choice D, either A or B. Correct answer: a positive. Question 7. When a positively charged sphere is brought near a metallic sphere, it is observed that a force of attraction exists between the two. It means that Choice A, the metallic sphere may be electrically neutral. Choice B, the metallic sphere is necessarily negatively charged. Choice C, nothing can be said about the charge of the metallic sphere. Choice D, the metallic sphere may be negatively charged. Correct answer: A and D. The metallic sphere may be electrically neutral and the metallic sphere may be negatively charged. Question 8. The cross-section area and length of cylindrical conductor are A and L respectively. The specific conductivity varies as sigma x equals sigma naught into L divided by root x, where x is the distance along the axis of the cylinder from one of its ends. Compute the resistance of the system along the cylindrical axis. Choice A, the electric field E of x at each point in the cylinder is E of x equals 5 × V naught into root x divided by 2 × L power 3 by 2. Choice B, the resistance of the system along the cylindrical axis is 2 × root L divided by 3A × sigma naught. Choice C, the current density is constant throughout the length of the cylinder. Choice D, the electric field E of x at each point in the cylinder is E of x equals 3 × V naught into root x divided by 2 × L power 3 by 2. Correct answer: A, B and D. Question 9. In two cases, two identical conducting spheres are given equal charges, in one case of the same type whereas in another case of opposite type. The distance between the spheres is not large comparing with the diameter. Let F1 and F2 be the magnitudes of the force OF interaction between the spheres as shown, then. Choice A, F1 equals F2. Choice B, F1 greater than F2. Choice C, F1 less than F2. Choice D, information is not sufficient to draw the conclusion. Correct answer: F1 less than F2. Question 10. The potential of the field inside a charged sphere depends upon the distance from its center to the point under consideration in the following way. V equals A into Rn plus B, where A and B are constants if the charge is uniformly distributed within the sphere, then the value of n is Choice A, 1. Choice B, -1. Choice C, 2. Choice D, -2. Correct answer: 2. If this video is useful to you, please like, share and subscribe. Thank you.